All right, here's an example of a problem from 6.3 which I've assigned, which is quite complex. Hopefully this video here will work. I'm at school. Nobody else is here with me, sadly. Just me and my computer. All right. So we are looking at sampling distributions, and in particular, this one is regarding the sample of the population standard deviation. What a mouthful. All right, we begin with looking at our set, weird, but just three numbers, 2, 4, and 9. See that? So the first thing it asks us is for the population standard deviation. Ignore all this samples that they've listed out. We're going to do this. Best way to do that, head over here to Google Sheets, and we're going to find some empty spot here. Oh, look at that. I've actually set it up here for a previous problem. And we're going to type in those three numbers, 2, 4, and 9. 4, and 9. All right. Now, to get this formula here to be a standard deviation, let me delete it all, first of all. And boom. Again, we start with that good old equal sign. And then we type in STD. And be careful, you want the standard deviation of the population, P, that one, entire population. And again, I want to click from this cell to that cell. There it goes. Boom, enter, boom. 2944. So we come over here and we type in 2944. 2.944. Check. Fantastic. Lovely. Next, we now have to come up with the sample standard deviations of these mini sets. Okay? And notice they're all of them, but each one is a sample. So our first one here, now it might seem odd, but we've only got 4, and yet we've got 9 of them listed up here. And that's because some of these have the same standard deviation. So next we're going to come over to our spreadsheet, and we're going to enter all those possibilities. So the first possibility was, I think, 2 and 2. And then we had 2 and 4, and 2 and 9. I have my formulas already loaded. Again, I'll show you which formulas I'm using. 4 and 2, 4 and 4, 4 and 9, 10 and 2, 10 and 4, and, not 10, 9, 9, 9, 9. Sound like I'm taking German, but I'm not. All right, it should be obvious. Standard deviation is 0 for 2 and 2. Standard deviation for here, be careful how you type this in. Notice I'm using the standard dev S for sample, meaning this is 2 and 4 is not the complete population, it's just a sample of the population. Okay, click on those two, bam, 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 bam. Next, we want the mean of all these. All right, well, hold on, before we get the mean. So now I come over here and I go, okay, I know we have a lost mouse, there it is. My first smallest one is 0. I think they said something about ascending order. So 0, how many zeros do we have? Well, we look over here, and I have 1, 2, 3. So the probability will be 3 out of 9, because there's 9 total. Next smallest standard deviation, 1.414. So over to here, 1.414. Again, how many 1.414s were there? Well, hopefully you can see 2 of them in the list there. 2 divided by 9. And then over here, I think 353 was the next one. And that 2 was 2 out of 9. Sorry about that. My cameratographer getting lost in the bushes. And 495 was my last one. That 2 was 2 out of 9. Nice work. Okay, so you got your standard deviations of your samples. Finally, it says, find the mean of the sampling distribution of the sample standard deviations. So I got to go back to that list, and I got to find the mean of these. So right down here at the bottom, again, a little formula, average C1 to C9. So the average of all those. Okay, and what was that number? 21998. So that's going to round up to 2200. So coming over here, 2.200, check. Nice work. And we have one last part here. Do the standard deviations target the value of the population standard deviation? Well, we look up here at the top. Look at our population standard deviation, 2.944. Here, 2.200. Now, they may look somewhat close to each other, but relatively speaking, they're almost a full unit apart. It's 0.7. Okay, so I'm rounding up a little bit. But compare 0.7 to 2.2 and to 2.9. So that's almost 30, 25%, thereabouts. So these do not target each other. They are not close. So I think option B here, standard deviations do not target, samples deviations do not target the population standard deviation. Therefore, sample standard deviations are unbiased. No, we want biased. Are biased. This one here, samples deviations do not target, therefore sample deviations are biased estimators. Check. Hopefully that makes sense. Sorry for having to make another video on top of it for you to watch, but that'll hopefully get you through 6.3.